Hi everybody, today we're going to have a look at inflation and depression, and hopefully we can solve a few problems involving that. So inflation describes a decrease in the purchasing power of money. So if inflation rises, what you could have bought yesterday you won't be able to buy today. So another way to think about it is it's when wages stay constant and the price of products increase. So if the inflation rate was a constant 4% per annum, so every year products increased by 4%, a $2,000 widget would increase in cost. And the first year it would multiply by 1.04 and then by 1.04 and then 1.04 and do that 6 times. And that's where that 1.04 times to the power of 6 comes from. And in 6 years' time, it would cost $2,530.64. Thus, if wages didn't rise, the purchasing power of the $2,000 has decreased by $530.64. You would be able to buy less with $2,000. Similarly, if the inflation rate rose in the first year by 5% and in the second year by 4% and the third year by 10%, you can work out the amount of inflation that's incurred over the 3-year period. So it's a similar process to what we did up here. You take the $100 that we started with, then you multiply it in the first year by 1.05, then by 1.04, and then by 1.1, which is increasing by 10%. Now, if we regroup this so that we do all the multiplication together, you'll get 100 times by 1.2012, and that's actually telling us the inflation over the 3-year period, which is 20.12%. So if we did this calculation here, the product would now expect to cost $121.12. So what we could have bought with $100 3 years ago, we can now buy for $121.12 today. Depreciation is different. Depreciation is how much a product, an asset reduces over time. So generally due to wear and tear. It could be also because of the products become cheaper over time, say like an electric car. But generally it's wear and tear. So the estimate of the value at a point in time we call the book value. So you have the purchase value and you have the book value. And the book value is equal to the original cost minus the written. Is not sure that's actually the case. All right, I'll go with it as the original cost minus the written down value. I'm sure I've gotten that out of the book. The residual value is the value at the end of its product life. So we can depreciate products using 3 different methods: a straight line or flat rate depreciation method, a unit cost method, or a diminishing balance method. So in the straight line method, all we do is work out the depreciation in the first term and then apply it for all future terms. It's just like a arithmetic sequence. What is an arithmetic sequence? You have to be a little bit careful with it, though. I'm going to show you one case where it doesn't quite behave like an arithmetic sequence like you think it would. The Jack's bike depreciates at a constant 5% per annum using the straight line depreciation method. If his bike costs $5,000, how much is it worth in 5 years? So this is at the start of the year. This will be at the end of the year. So we have to be a little bit careful with our subscripts. So if the yearly depreciation is 5%, that's $250 per year. Logically, we're going to have to apply it five times. But if we use the AP formula, this is only going to let us do it 4 times. So we'd have to use T6 rather than T5 to get the answer that we expect. And you can see here, there's the original cost. And if it's depreciating 5 times, that should be minus. And you'll get the figure that you're looking for. And you can see it here in a table. At the beginning, it was $5,000. At the end of the first year, at the end of the second year, and at the end of the 5th year, 1, 2, 3, 4, 5 depreciations, it's 3,750. So in some ways, it's easier to think about it as Tn equals the original cost plus n times d, not n take 1d, which is what we're used to with arithmetic sequences. So that's the flat rate method. Just an arithmetic progression, work out the interest once, and away you go. Unit cost method's a little bit different. With the unit cost method, you work out the total number of units, how many units were used up during a period, multiply the proportion, and find out the cost of each unit. So easier done than explained. So a photocopier purchased for $20,000 has a residual value of $8,000 and expects to produce 1 million copies. So if the copier produces 100,000 copies in the first year, calculate its first year depreciation in the book value of the photocopier. So here we go. Depreciation per unit. So it has the amount of depreciation in the time that the product is owned is $12,000 because you've bought it for this, you're going to sell it for this. You're going to use up $12,000 of its serviceable $20,000 life. And in that time, you're going to produce 1 million copies. So we can find out from that the cost per unit. It's going to be $20,000, take $8,000, which will be $12,000, and divide that by 1 million, and that gives you 0.012 per unit. Shall we check that? Let's check it. Make sure that I'm not doing anything silly. I'm just going to bring my calculator up. Where's my calculator? There it is. Right here. Give it a bit of a clear. And we'll say $20,000 minus $8,000 gives us that. Divide that by 1 million. And we get our 1.2 cents per unit. So, okay. So if we did $1,000 worth of 100,000 copies and multiplied that by 1 cent, that'll give us our $1,200. Let's test that. Multiply that. 1,200. No, not by 1,200. Multiply that by 100,000. There's our 1,200. So we know now that its book value after the first year is the $20,000 we started with. Take away the amount that it depreciated because we used some of it up in copy, and we've now got $18,800 worth of photocopier left. That if we sold it this year, that's what we'd sell it for based on how much we'd used it. And that could keep going over multiple years. Reducing value depreciation is a little bit different. Just going to get this out of the way. It's as opposed to a flat rate, which we did here. This is going to be a sort of like a reducible loan. So in this case, the value of a car is $25,000 and it depreciates 7% per annum over 5 years. So in the first year, it'll be 93% of its original value. And then the next year, it would be 93% of the previous year's value. So if you can imagine, we're going to repeat this calculation 5 times. Each year, we're going to depreciate whatever it was the year before. And if we do that calculation, we'll find out that our $25,000 car is now worth $17,392. If it's not so obvious what I've done here, let me show you a little bit clearer. If I go equals 2500, let me grab this symbol from up here. Oops. Go down. Times by 0.93, that would give us the first year's depreciation. And then if I did that again, that would give me the second year's depreciation, and the third year's depreciation, the fourth year's depreciation, the fifth year's depreciation. A little bit like our inflation calculation earlier. We would be able to work out the depreciation. Now, if the method of depreciation is not explicitly stated and it's not obvious that it's looking for the unit cost method, we should use the reducing value method. So let's do one. Here we go. A company's purchased a factory machine for $51,000 in January 1 of 2015, so the start of 2015. The machine is expected to have a salvage value of $6,000 at the end, so it's going to have a usable value of $45,000, the cost minus residual value. And during its useful life, it's expected to be used for 5,000 hours. Now, here are the hours that it was used for. So what I did here was I created a little spreadsheet to work it out. Here it is. So it started at 51,000. It went to 6,000. The difference was 45,000. There was 5,000 units. It used 1,200 units in the first year. So its depreciation was this difference So what was it? It was B8. So it was the actual units used divided by the total number of units that it can do, times by the value of the product. And that gave us the depreciation of 10,800. Subtract that from the original value, and we now have a book value of $40,200 at the end of the first year. Rinse and repeat for every subsequent year. If you want to think about it, you can have a look at this up here, and that tells you the formula that I used to make this work. You can do something similar with your class pad. Go away. Right, straight line method. The straight line method would just be, it's going down by $45,000 a year over 5 years. Divide that by 5, it's going down by $9,000 a year. And then you can work out each year thereafter. With the reducing value method, 5 years, we don't know the interest. We know that the present value is 51,000, the future value is 6,000. There's no payments being made. One calculation per year. What's the percentage rate? 34.81%. So it's reducing at a rate of about 35% per year. And then you can apply that percentage to each year, and you'd get its book value at the end of each year. And you can see here, year 5, with a bit of rounding error, it's worth $6,000 as required by the problem. So here we have 3 different ways of working out the depreciation, and depending on which one gives the company the best resale or taxation benefit or whatever, they'll use the one that's most appropriate. And there are accountants that spend their entire life doing these things. So that's inflation and depreciation in a nutshell. I hope that helps, and you can see how to use your calculator and your spreadsheets to solve these problems. So good luck, everyone.